Okay, we're going to start with factoring. So what does it mean to factor? It means to write as a product of other polynomials, which means you are trying to figure out what would fill in your two parentheses that make your rows and columns on your box. Because remember, your trinomial is what you get after you multiply and fill in your boxes, and then you combine like terms. So to start off factoring, what you need to do is you need to write your A, B, and C coefficients. So our A coefficient for our first example is 1. Negative 13 is our B coefficient. It's our X coefficient. And then C is your constant, and it is a positive 22. So after you fill in your A, B, and C, you have to then play your X games. So remember, we're going to fill in the top and bottom of our X, and we're going to take the product of A and C coefficients. So if I look at my A and C coefficients, that's 1 times 22. So 22. And then the bottom of my X is going to be filled in by just my B coefficient, so negative 13. And now I'm trying to figure out what two numbers that will multiply to 22 but add to 13. So I'm thinking of 11 and 2. Now, once you get numbers, you may have to play with the signs, maybe make them both negative or one negative, one positive. Since my product is positive, they're either both negative or both positive. But because I've got to add to a bigger or more negative number, they're going to have to both be negative. Now, you always want to check your calculator to make sure that your two numbers work. So I should be able to multiply negative 11 times negative 2 and get a positive 22. And I should be able to add negative 11 and negative 2 and get a negative 13. So you always want to check your math, because if you're off on your X numbers, then you're going to be off on your factors. So now I'm going to take this to my box, because all this is helping me do is get my diagonal boxes, and those should add together to make negative 13x in my original problem. They should always add together to make that original middle term. So now I'm going to fill in the rest of my box. So this x squared term is going to always fill in the top right box, and your constant is always going to fill in the bottom right box. Now, to get your factors, now you're going to think, okay, what would I have to multiply for my row and my column to fill in those boxes? And hopefully you're thinking x and x here to make x squared. And now I can kind of use my multiplication. What would I multiply x by to fill in this box for negative 11x? And that would be negative 11. What would I multiply x by to fill in this box for negative 2x? And that would be negative 2. Negative 2 times negative 11 does fill in the box for negative 22. So now I know that my row and my column are x minus 11, x minus 2. And those are my factors. I would multiply x minus 11 and x minus 2 to get the product of x squared minus 13x plus 22. So now we're going to work in the rest of them. Okay, so when you notice that your A is not a 1, you have to check for your GCF. So I'm going to put this over here. GCF. A is not 1. Okay? So you're just going to kind of have to remember that. Okay? Well, I know that they don't have a common GCF because nothing can divide out of 7, 3, or 2 and leave me with a whole number. So I'm going to continue just like I did with example 1 with writing down my A, B, and C coefficients. Make sure you include the sign. So I'm going to multiply A times C, that's 6, and I have to add to a negative 7. So 3 times 2 will get 6, but 3 plus 2 won't ever get me to a negative 7. So I believe my answers are going to be 6 and 1. Again, I'm going to have to look at my signs, because if I add a positive 6 and positive 1, that's not going to give me a negative 7. So they must both have to be negative. And again, I'm going to check my math. Negative 6 times negative 1. They do multiply to positive 6. Negative 6 plus negative 1. They do add to negative 7. So those are my values, and now I'm going to fill in my box. So negative 6x, negative 1x. And again, those should diagonal should add to your middle term in your original trinomial. And now I'm going to fill my boxes. So I've got 3x squared going in the top left box. And then I have plus 2 going in the bottom right box. And now I'm going to start filling in. And if you're stuck and you're not sure what to do, the best thing to do is think about your GCF. For this column, I need to find the GCF of 3 and negative 6. Well, I know that 3 divides out of both evenly. And there's got to be an x here and an x here for 3x squared. So now I'm going to check my multiplication. Well, 3x times x, fill in the box for 3x squared. Yes, so I have both of my terms here. And now I'm going to use my multiplication skills to see 3x times what is going to fill in the box for negative 6x. And hopefully you're saying negative 2. What times x is going to fill in the box for negative 1x? Negative 1. And will negative 1 times negative 2 fill in the box for positive 2? Yes. So my factors are x minus 2, 3x minus 1. So those are my factors. I would need to multiply x minus 2 and 3x minus 1 to get the product of 3x squared minus 7x plus 2. All right, so now I'm over here, example 3. Negative 4x squared minus 8x plus 5. I'm trying to figure out what would I need to multiply together to get this product. And I noticed that my a is not a 1, so I'm going to think GCF. And I know I can divide, 4 can divide out of 4 and 8, but 4 cannot divide out of 5 evenly. 2 can divide out of 4 and 8, but 2 cannot divide out of 5 evenly. So this does not have a GCF. So negative 4, negative 8, positive 5. So now I'm going to multiply my a and c coefficients to fill in the top of my x, always, negative 20. And my b coefficient is going to fill in the bottom. So I'm thinking of two numbers that I can multiply to make a negative 20, but will add to make a negative 8. So I'm going to think of two numbers. So I'm thinking 4 and 5, but 4 and 5 won't ever add to make a negative 8. Let's see. 10 and 2 will. So 10 and 2. And since I noticed that my product is negative, one of these has to be negative. So now I'm going to look to my sum. I have to add these two numbers together to get a negative 8. Well, if I make 2 negative, my answer for my sum, my addition, would be positive. So that tells me that the 10 has to be negative. So now I'm going to fill in my box. So I know that negative 10x, negative 2x, positive 2x, that will add to make a negative 8x because my diagonals have to add together to make my middle term. Now, it does not matter where you put your numbers for your x games here in the diagonals because I'm going to use the GCF to figure out what goes on the outside to make my rows and columns. I'm just filling in the rest of my box here with my leading coefficient and my constant. And now I'm going to think GCF. What's a common GCF of 2 and 4? 2. It's got to be an x because this has to be x squared that I left off. Okay, so this has got to be a negative 2x because negative 2x times a negative 2x fill in the box for negative 4x. This has got to be a plus 1 because 2x times 1 will fill in the box for 2x. So now I'm thinking what times negative 2x will make negative 10x? And that's going to be a positive 5. And 5 times 1 will fill in the box for positive 5. So my factors are negative 2x plus 1, 2x plus 5. Negative 2x plus 1, 2x minus 5. Okay. So now we're going to look at some more factoring. We're going to look at perfect square trinomials, and what you need to know is perfect square trinomials are where you have the exact same factors in both parentheses so that you can write it as 1 parentheses to the power of 2 because both are the same. So if we look here at x squared plus 26x plus 169, I kind of use that complete the square visual that we used when we talked about completing the square. So I've got x squared and 169, then I've got to think, how could I split up my 26x so that I get them evenly? And if you notice, 26 can be divided by 2 evenly, so that would make 13x here and 13x here. So that means that my parentheses would have to be x and 13. And they're both positive, which means I can now write that as x plus 13 squared. And that's a perfect square trinomial. So on the next one, I've got 9x squared minus 24x plus 16. So I can divide out, or I can make my 9x squared here, my 16 here, and then I'm going to think, how could I split up my negative 24x evenly, and it can be divisible by 2, so this would be a negative 12x and a negative 12x. So now I just got to think, if these were boxes, what would go here and here? And they have to be the same. So 3x and 3x. And then 3x times what's going to make a negative 12x? Minus 4. What times 3x going to make a negative 12x? Well, minus 4. And then if I check my multiplication, will I get a positive 16? Yes. So my factors are 3x minus 4 times 3x minus 4. And that's going to get me to 3x minus 4 to the power of 2, because both factors are the exact same. Now this only works when you can make a box where the same terms will multiply together. So basically it's like you're unsquaring those numbers. Okay, you could still go back up to here and factor using the x gains and your a, b, and c coefficients. Just remember, if your a is not 1, you have to check for your GCF. Okay, the difference of two squares is when you get a factor where it's the same terms, but one parentheses has addition and one parentheses has subtraction. So I'm looking here. So I'm looking at 9x squared and 36. Well, if you notice, we're missing that x term, which tells me that the x term is 0. So we're going to write that. X term is 0. Okay? Which means one of these has to be positive and one of these has to be negative, so when I add them together, I get 0 x's. Okay? So I'm thinking this would be 3x and 3x. Now, 3x, so now I'm going to think also too, what numbers would I have to multiply to get a negative 36? Well, one's got to be 6 and one's got to be a minus 6 because they have to be the same. So if you notice, here I have 3x plus 6, and then on the other side I have 3x minus 6, because 3x times 6 would be 18x, negative 6 times 3x would be a negative 18x, and when I add those together, I get how many x's? 0. Okay, so you can see 3x, 3x, 6 and 6, but one's addition, one's subtraction. So now we're going to kind of use that same thing over here. So this would be x and x. So I've got to think, how could I divide out evenly where I get the same number here and here? And notice, this is not a difference of squares because you're thinking 9 and 9, but 9 times 9 will not get to 18. So this is not one. Use factoring above. So you're going to have to factor it using it the other method. You may have to even complete the square. Okay?